All right, in this video I'm going to work through the 3 practice problems you were asked to do this week. As always, let me know what questions you have or what arises after the fact on these. So let's get right into it. This first one, we want to show that this left side, 2 sine theta plus 3 cosine theta quantity squared plus 3 sine theta minus 2 cosine theta quantity squared is equivalent to 13. So there was some confusion this week in what this equals or what we were asked to do. You were asked to show that this left side evaluates to be 13. Some of your classmates did a really unique way of working through this where you showed that it ended up being a true trig identity as well, and that works also. So when we go through this, 2 sine theta plus 3 cosine theta squared is equivalent to 2 sine theta plus 3 cosine theta times itself. So if we write this out longhand, there should be a 2 there, 2 sine theta plus 3 cosine theta. So here's what we have. So we multiply this out by distributing, so 2 times 2 is 4, and we have a sine squared theta when we multiply 2 sine theta by 2 sine theta. Now 2 times 3 is going to be a positive 6, and that's a sine theta times cosine theta. Let's just be consistent and put them in alphabetical order. So cosine theta, sine theta. And then we have another 6 cosine theta, sine theta when we distribute the 3 cosine theta to 2 sine theta. So we have a second one, so 6 cosine theta again, sine theta. And now finally we're taking 3 cosine theta times 3 cosine theta, which is a positive 9 cosine squared theta. So there's our first one multiplied out. And if we take this and we do the same thing to the 3 sine theta minus 2 cosine theta, it ends up being something that looks like this when we distribute it. So we have 3 sine theta times 3 sine theta, which is a positive 9 sine squared theta. And then we have a 3 sine theta times negative 2 cosine theta, and there's 2 of those. So we'll actually have a negative 12 cosine theta sine theta. And finally, the 2 cosine theta times 2 cosine theta, which are both negative, ends up being a positive 4 cosine squared theta. So there we have it all worked out, and now we can simplify this down. So the 6 cosine theta sine theta and 6 cosine theta sine theta makes 12 of those. So we have 12 cosine theta sine theta. And this actually cancels to 0 with the negative 12 version of that. So in the end, what we're left with here is we are left with a 4 sine squared theta. This part's gone, remember. A positive 9 cosine squared theta, a positive 9 sine squared theta, and a positive 4 cosine squared theta. So what we can do here is we can group the 4 sine squared theta with 4 cosine squared theta to get 4, because sine squared theta times cosine squared theta is 1, and if we factor that 4 out, we get 4 times 1. And similarly here with the 9 cosine squared theta, 9 sine squared theta, this is 9 times 1 when we factor the 9 out of that, so we're left with 4 plus 9, which is equal to 13. So there we have it worked through. We wanted to show that this left side, when we expand it and then simplify it as much as we can after it's been expanded, is equivalent to 13. And there we have it. On to number 2. Number 2 is multiplying as well. So this left side or right side we can actually ignore entirely. This is what we're expecting this to come out to be when we simplify it. So I'm not going to pay attention to that right side. I'm going to do everything I can with the left side to clean it up and then see what's left. And what's left should be this sine squared theta over cosine theta. So again, with this one, we distribute the 1 times 1, which gets us 1. We distribute the 1 to 1 plus 1 times 1 over cosine theta, which is equivalent to just that 1 over cosine theta. And now we distribute the negative cosine theta through. So we have a negative cosine theta, and then a negative cosine theta times 1 over cosine theta, which is negative cosine theta over itself when we multiply that out. So there's what we have when we multiply this or expand it by distributing. And now we can clean this up. We have 1 plus 1 over cosine theta minus cosine theta. And anything divided by itself is 1. So this reduces to negative 1. And the positive 1 and negative 1 reduce down. So now we're left with 1 over cosine theta minus cosine theta. And if we want to subtract these, we need to get a common denominator. And that common denominator is going to be cosine theta. So we already have the left side over cosine theta. And now on the right side, we need to multiply this by cosine theta over cosine theta. So we get this cosine theta in the denominator. Well, what we're doing here is we're actually multiplying this by cosine theta, this being the numerator of it, so we're left with a cosine squared theta because we're multiplying cosine theta by itself. And now we can subtract these. So we have 1 minus cosine squared theta all over a cosine theta. And if you recall, this numerator, what we're expecting it to become is a sine squared theta. Well, this is the Pythagorean identity just rearranged to equal sine squared theta. So this 1 minus cosine squared theta is equivalent to sine squared theta. And there we have what we're set out to show, that this initial expression is actually the same thing as sine squared theta over cosine theta. So we have that one worked through. On to the last one. This time, we're subtracting two fractions. Again, we're not paying attention to this right side yet. This is what I'm expecting it to become. When we are asked to show this identity, we're asked to show that this left side is actually equivalent or identical to the right side. So when we subtract two fractions, we need a common denominator. So that common denominator, we have to multiply the two together. So I want that denominator to be a 1 minus cosine theta times 1 plus cosine theta. So that's what I want this to become. So I need to introduce the part that's missing into each of the two fractions. Well, on the left fraction, I need to introduce the 1 plus cosine theta, so I'm going to multiply by that. If you see what I did there, I actually just did 1 plus cosine theta times 1 plus cosine theta over this. So this actually is just a fancy way of writing 1. And then on the left side, I want this to be the same thing. I want it to be 1 plus, or the right side, I'm mixing those up, 1 plus cosine theta, but I also want that 1 minus cosine theta there. So I need to multiply the right side by 1 minus cosine theta. And then we initially had a sine theta there, so times sine theta. And now we're set to go. We have this common denominator of 1 minus cosine theta times 1 plus cosine theta. So when we distribute through and write these as one fraction, I have a sine theta plus a cosine theta times sine theta. And then on the right side, I'm going to subtract this quantity, a 1 times sine theta, so a sine theta, minus a cosine theta sine theta. I got that minus by distributing the negative into the sine theta, or vice versa, whichever way we want to distribute. So there we have it. And this is all over that common denominator of 1 minus cosine theta times 1 plus cosine theta. And now we can set out and reduce this a little more. When we're subtracting this whole expression on the right side. So I need to distribute this negative through first. So I have a sine theta plus cosine theta sine theta. Nothing changed there. And now we have a minus sine theta plus a cosine theta sine theta. And that plus turns into the plus because we have a negative times a negative. And this is all over. Here we have it. 1 minus cosine theta. I'm not going to multiply this out yet because I want to see what happens. 1 plus cosine theta. If we look at our original, what we want to show this as, there's nothing dealing with that 1 minus cosine theta sine theta. So I'm not going to mess it up though and expand that out yet because I want to see what happens in the numerator. So cleaning up our numerator now, sine theta cancels with negative sine theta. And then we have a cosine theta sine theta plus a cosine theta sine theta. So we have 2 cosine theta sine thetas in the numerator. And now I'm not seeing anything that's going to reduce with the denominator as it is right now. So I'm going to multiply that out. So 1 times 1 is 1. 1 times cosine theta is a positive cosine theta. Cosine theta times negative cosine theta times positive 1 is a negative cosine theta. So there we have those are going to reduce. And negative cosine theta is actually going to give us a negative cosine squared theta. So now let's clean up what we can in the denominator. Our numerator stays put. That doesn't change. So 2 cosine theta sine theta. And then our denominator, well, we have a cosine theta, negative cosine theta reduced. So we're left with a 1 minus cosine squared theta. And just like the last problem, this denominator is a Pythagorean identity. It's just rewritten in a different way. So we have 2 cosine theta sine theta all over 1 minus cosine squared theta is equivalent to sine, 1 minus cosine squared theta, yes, is equivalent to sine squared theta. So now we can actually reduce this a little more. This one's taken a while, but we're getting there. We have 2 cosine theta times sine theta. So we have a common factor of sine theta in the numerator and denominator. So we can reduce one of those out. So the sine theta divided by sine theta times sine theta actually gets rid of the squared there. So we're left with a 2 cosine theta all over sine theta. And the reason we did that, I don't feel like that's a good explanation, is we had a sine theta in the numerator as a factor, and the denominator was a sine theta times itself. We just write that in a little different way, and we reduced one of those factors to 1. So that's why there's only a sine theta left in the denominator. So there we have it. The 3 problems from this week's practice worked out. Go ahead and respond to the reflection prompts that are in the Google Doc attached also. Hope this video helped.